Well, here you have it. We have a great topic for you today. It's called standard position. So let's go ahead and review our positive trig quadrants, okay? Hopefully you recall our goofy little saying, so go ahead and copy this quadrants down. Let's label them 1, 2, 3, 4. And our saying, or again, you could use your own, was all students tip cows. And this is where they're positive, okay? So they're all positive in quadrant 1. Now remember, sine is positive in quadrant 2, and it's going to bring along its friend, its reciprocal, cosecant. Tangent's positive in quadrant 3, and it will bring its reciprocal along, cotangent. And cosine's positive in quadrant 4, and it brings its reciprocal along. Now hopefully we're going to answer some nice questions about these. Let's try a few. All right, now it looks like there's quite a few, and we want you to jot them down. They're fairly typical multiple choice questions. So instead of copying all this down, basically you need to say sine theta is greater than 0, secant theta is less than 0. And the question every time is, what quadrant does the terminal side lie in? So all these questions, you're going to make a real quick chart, and you're just going to say to yourself, all students tip cows. All right, we're not doing it in our heads. We want it written down every time. And now we're just going to carefully read what they told us. What does it mean if sine is bigger than 0? Are you a positive or a negative? Think about that. If you're greater than 0, basically I'm telling you that you're a positive number. So I need to ask myself, where is sine positive? Well, it's definitely positive in all, and it's positive where you see the S. So what that tells me I can do is I can kill these two quadrants. Okay, put a big X in them. Your answer is now a 50% choice here. It's either 1 or 2. Now read your second piece of information. Secant theta is less than 0. Well, what does it mean to be less than 0? Well, if you picture your number line and here's 0, numbers that are less than 0 are negative. Okay, so I'm telling you secant is negative. Where do you have to be? Well, what's special about quadrant 1 is all of them are positive. So if I'm telling you secant's negative, can you be in the quadrant where they're all positive? No, so we can easily kill that one out. And let's just verify that 2 makes sense. Sine is definitely positive because I see the S here. And the only other positive one would be its reciprocal, which is cosecant, meaning everybody else is negative. So my answer would be quadrant 2. All right, let's try another one, number 2. If the tangent of an angle is negative, so let's put that into our own lingo. Tangent theta is less than 0. That means negative if you're smaller than 0. And secant is positive, so SEC is bigger than 0, which means positive. What quadrant does the angle terminate? All right, so make your quick X and Y axes, talk to yourself, all students tip cows. And now let's carefully go through and eliminate them. All right, tangent is negative. Well, you can't be where tangent's positive. And I know everybody's positive in the first, and I know tangent's positive in the third, and I know I can't be there because we just said tangent has to be negative. So it's either 2 or 4. Now let's go to our second piece. Secant is positive. Well, who does secant belong to? It's the reciprocal of cosine. So I need to be where cosine is positive, and that's definitely where the C is. So I'm going to kill this quadrant, and my final answer should be quadrant 4. Maybe you've got the hang of it, maybe you're thinking it's easy. We're going to try a couple more. So feel free to pause it, try number 3 here on your own, and see what you come up with. So like I said, pause it, try it on your own. So just from reading, I said sine is negative, so it's less than 0, and cosine is negative, so it's less than 0. So if sine is negative, I know I can't be where sine is positive, and it's positive in the first and second. Therefore, I'm definitely in either 3 or 4. And cosine has to be negative. Well, I know cosine's positive where I see the C, so I can kill that. And hopefully you said quadrant 3 is our winner. All right, let's try another one. Number 4. Cosine theta is greater than 0. Cosecant theta is less than 0. Okay, so again, all students tip cows. Read them to yourself, pause it, try it on your own, and see if we get the same thing. All right, so this line that says greater than 0 tells me positive, and this one that's less than 0 says negative. And I just want to be clear, I'm just getting that from the number line. If I'm bigger than 0, I'm a positive number. If I'm smaller than 0, I'm a negative number. So cosine has to be positive. Well, cosine's positive in the all and in the C. So I'm going to kill these two. So out of the two that are left, I want cosecant to be negative. Well, remember, in the first quadrant, everybody's positive. So cosecant can't be there if it's negative. Therefore, it's got to be in quadrant 4. All right, just a couple more left here. Tangent theta is 2.7, and cosecant theta is less than 0. All right, now I've never given you one where they actually gave me a value, but just ask yourself, all we care is whether things are positive or negative. So if tangent's 2.7, what they're really trying to tell you is that tangent is positive 2.7. All you care about is its sign, S-I-G-N, whether it's positive or negative. And if cosecant's less than 0, I'm saying that's negative. All right, so if tangent's positive, it's where I see a T, and it's in the all quadrant. So I can kill these two. So my answers are either 1 or 3. And cosecant has to be negative. Well, I can't be in the first because they're all positive there, so I've got to be in the third. All right, we absolutely love this question. This one's going to make you think a little bit. Sine theta, or A, is greater than 0, and they want to know where sine A times cosine A will lie if it's less than 0. All right, so let's slow down and think about this. If sine A is bigger than 0, I am telling you it's a positive number. Now think about this. You know that sine A here is a positive number. And you know when you multiply sine A times cosine A, you're getting a number less than 0. You need to get a negative value. So what does the sine of cosine of A have to be? Is it going to be positive or is it going to be negative? Well, let's pretend it's positive. What's a positive times a positive going to get you? A positive. Well, clearly that's not negative. So it's not going to be positive. Cosine A is going to have to be a negative value because I need a positive times a negative to get me a negative. Now, that doesn't quite answer the question yet. I need to figure out what terminal or what quadrant I lie in. So all students tip cows. I know sine is positive, so I can kill these two. I'm where the S and the A are. And I know cosine, we just said, had to be a negative. So I can't be where they're all positive. That leaves me in quadrant 2. All right, I've got one more of this type before we move on. Sine theta equals cosine theta. All students tip cows. What quadrant do you lie in? Well, if two things are equal, that means they're going to have the same sign. So if sine's equal to cosine, hopefully you're thinking if you're 30, 60, 45, do they have the same value? Well, remember the sine of 45 is radical 2 over 2, and the cosine of 45 is radical 2 over 2. So the angle itself would be 45, which tells me that I lie in quadrant 1 for sure. Now, that's where they're both positive. But they can both be negative as well, and they'll have the same value. Negative sine of 45 and negative cosine of 45 have the same answer. Negative radical 2 and negative radical 2 over 2. So they're both in quadrant 3. So if I went too fast for you there, say to yourself, they're both positive here, and they're both negative here. So they have the same sign. They are equal to each other. Before we jump into this next problem, we got to talk about the bow tie. So anytime you draw a triangle in one of these quadrants, it'll look like a bow tie with all 4 of them together. So you should always go out, that's your hypotenuse, and you want to make sure you're perpendicular to the x-axis. Okay, so perpendicular to the x-axis. And then theta should sit at the origin. So let's draw the same thing in quadrant 2. I would go out, perpendicular to the x-axis, theta sits at the origin. Same thing in quadrant 3, I'm going to go out, perpendicular to the x-axis, theta at the origin, and in 4, same thing, out, theta's at the origin, perpendicular to the x-axis. So that's what I kind of meant by a bow tie. Anytime you draw these in one of the quadrants, make sure it's part of the bow tie. All right, we've got a few more questions tonight. This one says, given the point -4, -3 is a point on the terminal side of theta, what then what is tangent theta equal to? So just like we've been doing, quick sketch for all of these. Basically, you're just going to plot the point they give you. So they give you -4, -3. All right, so you're going to start at the origin, go -4, label it, then go -3, label it, and we have a right triangle. Notice that right angle's on the x-axis, kind of looks like our bow tie. And let's go ahead and figure out what our hypotenuse is. So -3 squared, that's just your quick Pythagorean theorem, minus 4 squared equals c squared, 9 plus 16 equals c squared, 25 equals c squared, c equals 5. And I just want to make a quick note that this hypotenuse is always positive. Okay? Hypotenuse is always positive. Now, your theta always touches the x-angle again, or x-axis. Please make sure your theta is in the x-axis, touching it. So, all I have to do now is evaluate the question that says, what is tangent theta? So if I say SOHCAHTOA to myself, that's O over A. My opposite, here's my hypotenuse, adjacent, opposite. Make sure you remember your basic trig there. O is -3 over A, which is -4. These two negatives make a positive 3/4. All right, very similar question. Given the point 3, -4, immediately stop and draw it. As you draw it, label the sides. You're going to start at the origin. You're going over 3, throw a 3 on it, then you're going -4. Make sure you call that -4. It wants secant now. All right, so a little Pythagorean theorem. Probably should have wrote my 3 up here. I'm going to put theta next to the x-axis, my right angle. If I do the Pythagorean theorem, I get 5 again. Okay, remember this hypotenuse is always positive. And based off where this theta is sitting, let me change colors here. Here's the angle, hypotenuse, adjacent, opposite. Remember, adjacent means next to your angle. We need secant theta. Okay, now remember, secant is the reciprocal of cosine. So I'm going to start with cosine. So co is A over H. So that's 3 over 5. So if I want secant, my answer is actually 5 over 3. Just make sure you flip that bad boy. All right, little trick here. Now they're not giving you a point this time. They're describing where you're sitting. They tell you cosine is -4/5, and they tell you tangent theta is greater than 0. So you don't actually know what quadrant you're in yet. You got to go back and think. So let's go all students tip cows. Tangent is greater than 0, so tangent is positive. So I can either be in all or the tan, so I can't be here or here. We'll kill those out right away. Now, what did they tell you about cosine? Well, it's a negative value, so you can't be where they're all positive. That means you have to draw your angle in quadrant 3. So again, you have to come out and straight down to the x-axis. Make sure that is where your right angle is, and your theta is always touching the x-axis. All right, let's quickly label our sides. Hypotenuse, adjacent, opposite. When I say SOHCAHTOA here, this is A over H. So that means this side is -4 over 5. I need to go get my missing side. So I've got A squared plus -4 squared equals 5 squared. A squared plus 16 equals 25. A squared equals 9. A equals 3. Now here's the catch. Don't fall for this. In your picture, this value, does it make sense that this is -4? Did you go from the origin left 4? So -4 makes sense. What would you have to put on this side? Would you put a +3 or a -3? Even though you got +3 as an answer, you have to be smart enough to say, my picture is going down. That's got to be a -3. Now, what is the value of sine? That's what the actual question is. Sine theta equals SOHCAHTOA, O over H. Sine is opposite, so that's -3 over 5. And notice they're going to try to trick you. They're going to put that +3 over 5 in, but don't fall for it. That's why you've got to sketch a picture. Okay, theta is a positive acute angle, and the tangent of theta equals 6/8. Find sine theta. So again, I first have to determine what quadrant I'm sitting in. Tangent's positive, so in my all students tip cows, I'm either in all or tangent, so I can kill these two. And here's the kicker here. You have to be a positive acute angle, okay? And it's the word acute, hopefully, that sticks out to you. And we've talked about acute this year already. Acute means that you are less than 90 degrees. So if you had to be smaller than 90, would you be in the first or third quadrant? Well, remember, the first quadrant is 0 to 90. So you'd have to draw yourself in the first quadrant. All right, so we're going to go out, perpendicular to the x. Theta's at the origin. Tangent is opposite over adjacent. So I've got 6, 8. Obviously, I'd do my Pythagorean theorem. Maybe you know this is a Pythagorean triple. So I know this side is 10. And sine theta then is opposite over hypotenuse. So in this case, 6 over 10. And you could reduce that, of course, if I would divide by 2 to 3/5. All right, let's try another one. Try just to figure out what quadrant you're in and get your triangle drawn in. Just pause it, see if you can figure out where your triangle's sitting. Okay, I know sine is negative, so I'm going to kill my all where it's positive and the s where it's positive. And cosine is bigger than 0, so cosine is positive. So I want to be where I see a c, so I'm going to kill this quadrant as well. So I've got to be in the fourth quadrant. Okay, your angle comes down and is perpendicular to the x-axis. Theta touches the x-axis. Okay, we're going to label what we know. Sine theta is negative 3 over 5. So say SOHCAHTOA to yourself. Sine is opposite over hypotenuse. So label my sides. Here's my hypotenuse, adjacent, opposite. My opposite is going to be negative 3/5. Now think about this. Does it make sense that this side was negative 3? And hopefully you're saying yes, because you went from here down. So negative 3 makes sense. Pythagorean theorem to get your missing side, maybe you know it by now. I'm definitely going to say it's 4. It's one of those Pythagorean triples, 3, 4, 5. And you're going to the right, so should you be a positive 4 or a negative 4? And hopefully you said positive 4. And now the question is, what is tangent theta? So back to day 1 of trig, SOHCAHTOA. Tangent is opposite over adjacent. Opposite is negative 3 over 4. So I'm going with choice B, negative 3 over 4. All right, last one of the night. They give us a point again. So let's go ahead and get our axes set up, and let's sketch it out. I need to plot the point radical 5, negative 3. Now maybe you don't know how big radical 5 is, but you know what direction you're going. It's positive. So go just draw a line. It's positive radical 5, and you're going negative 3. Connect, get your hypotenuse, label your theta. Quick Pythagorean theorem to figure out what your missing side is. I've got c to equal the square root of 14. And now it just says, state all 6 trig functions. So let's start with sine theta. We'll get its reciprocal is secant theta. Oh, we've got cosine theta, secant theta, its reciprocal, tangent theta, and cotangent theta. Lastly, I'm just going to mark my angle. Hypotenuse and adjacent are my two easiest. Opposite kind of means across from. All right, SOHCAHTOA. Make sure you can spell SOHCAHTOA by now. So sine is opposite over hypotenuse. So I get negative 3 over radical 14. And remember, you can't leave the radical on the bottom. So if I rationalize that, negative 3 radical 14 over 14. Now I just want to be clear, if you can break 14 down, you need to do that because it says simplest radical form. Fortunately, 7 and 2 are my only options, and neither of those are perfect squares. Cosecant means flip your sine function, and I'm going to flip this original one. I think that's easier. So I'm going to get radical 14 over negative 3. Cosine is adjacent over hypotenuse, so I get radical 5 over radical 14. Have to rationalize that, so I'm going to multiply by radical 14. Oh boy, this one's taking up space. I better put my work down here. So I'm back to cosine theta here. So I get radical 70 over 14. Oh, can I break 70 down? I'd say no, so I'm done there. So secant is going to be 14 over radical 70. And if I rationalize that, 14 radical 70 over 70. Now I can simplify 14 over 70. So I'm going to say 7 goes into 14 twice and into 70 10 times. And then I'm going to go back and get tangent, opposite over adjacent. So negative 3 over radical 5, which of course is negative 3 radical 5 over 5. And then cotangent. Oops, I'm going to have to put out here. I'm going to flip this guy. So I'm going to get radical 5 over negative 3. And there you have it. So take your time tonight, and we look forward to seeing you tomorrow.